Now we're going to move on to our second panel of the day. And I'd like to introduce Kristen Van Vliet, who is our Associate Provost and Professor of Materials Science and Engineering and Biological Engineering at MIT. In her unique role, Kristen oversees the development of MIT's campus and its overall operations and changes. This campus is literally her purview, an excellent perspective towards how MIT's campus has been used to investigate technologies. Furthermore, Kristen's role includes development of industrial relationships that can enable our local and global climate goals. So I'm going to turn things over to Kristen now, and she will moderate our next panel with Julie.
Thank you so much, Paula. And I'm happy to do that and follow on the excellent discussion we've had so far. So in this next panel, what we'll be doing is taking a look at what the MIT campus can do and is doing to follow up on the challenges that we just discussed. And the two panelists that I'll introduce to you today are Julie Newman and Joe Higgins. These are very, very important roles and important people in how MIT addresses our climate action plan, our commitments, and our way to use the campus as a living lab and a test bed to demonstrate the technology and the choices that we as people make to move the campus forward. So Julie, Dr. Newman, is MIT's Director of Sustainability, and in fact, our first Director of Sustainability. She's also a lecturer in our Department of Urban Studies and Planning. Further, she leads one of the teams that's working on MIT's vision for 2021 and beyond, so that sustainability and the response to the Climate Action Plan is integrated in what we do in the years ahead of us coming out of the pandemic response. But much more than that, Julie thinks about campus sustainability and sustainable development deeply, and over the past 20 years has devoted her career to that. She came to us from Yale, where she served in a similar role for many years, and since she's been at MIT since 2013, she's really helped MIT plan and move the needle with many people, including a close collaborator of hers on campus, Joe Higgins. Now, Joe is our Vice President for Campus Services and Stewardship at MIT, and in that role, since late last year, he and a team of 800 people are responsible for the planning, the construction, the maintenance, and the powering of the MIT campus. That's quite an impressive feat, and I'll show you through the numbers how important that is. But not just keeping the campus running as it runs today, but thinking about, with Julie and others, how it should run in the future as we think about us being part of the bigger world. And he, along with me, co-leads a task force work stream dedicated to thinking about administrative processes, including campus operations, in the coming years for MIT. So before we hear from Julie and Joe, I wanted to take a look at the campus. As Paula said, that is where I spend quite a bit of my time and quite a bit of my thinking. And through that and the interactions with Julie and Joe, I've come to think about how we respond to our commitment to the Climate Action Plan in a few ways. First, our MIT campus operations absolutely must reflect our Climate Action Plan commitment. That won't happen accidentally, it has to happen deliberately. And to that point, our commitment to that part of MIT's sustainability has to be integral to our decision making. It's not an add-on, it's not an extra, it's not a cost premium. It's integral to all of the decisions we make about how to operate the campus, how to add to the campus, and how to adapt to the climate through planning and execution of the smallest projects, and I'll show you one of those, and the biggest projects, and there's many of those. Finally, MIT is a living lab, and you'll hear that a lot in our discussion today because that really allows us to take the best of MIT's ideas and the people who love living and learning and working at MIT to pilot some of these research and education efforts, show and test which ones can work, not just for the campus, but as John mentioned, for the rest of the world. And we all make choices that contribute to shared success, the global success, the campus success, our unit success. So while we do need to think more than locally, we need to also make sure that we're thinking about what we do at home, at our campus, in our department. Okay, so let's take a look at the campus. This is an aerial view map from Google Maps, and what you see is the MIT, which we could say is this arrow right here, is embedded in an urban environment across from Boston and in Cambridge. And so the rough outline of the campus looks like this, something like a triangle. But by the numbers, what MIT is taking care of in Cambridge is about 170 acres. There's 18 residences on the campus. There's 26 acres of playing fields, as you can see over here. There's more than 30 gardens and green spaces that are intentionally placed around the campus, along with more than 60 public works of art. So it's quite an amazing place to work and take care of and think about in relation to the urban campus. MIT is often building. You can see in this somewhat dated image, and MIT is always changing, and you can see that in reference to this dated image. In this image, you see the MIT campus with a tennis court, which is no longer there. So that's in this section of the campus facing the river. And last year, MIT opened up a new thing. Instead of a tennis court, now you see a green space with something called the Hive, which was an effort that was launched by collaboration between students, staff, and Julie's team to make a sustainability garden. Now that's a small thing, but the effort that they put into planning, working together, and using this to learn about the climate in our local environment was quite important to the thinking and the growth of those folks who have since graduated from MIT and taken those lessons with them. And of course, Cambridge is not the only part of the MIT campus. We look towards the sky. We have Haystack Observatory, we have Wallace Astrophysical Laboratory, and Bates R&D Center in Massachusetts, along with MIT Lincoln Labs and the President's Office in DC. So the campus is not only in Cambridge in 02139, and it's not only in the US. We also have international research efforts, and we take equal responsibility for their impact and our approach to those projects, including as far away as Singapore. So with that in mind, we'll turn it over now to hear remarks first from Julie and then from Joe on how we can use the campus and our operations here as a test bed for the world. Julie?
Well, thank you, Kristen, and what a perfect setup. And thank you to Paula, Melissa, John, Richard for such an inspiring and thought-provoking introduction and panel. It set the stage for this discussion perfectly. I want to begin by saying that despite the distance from campus for many of us and from one another due to current circumstances, our connections as a community and our commitment to building a pathway forward for a sustainable and climate positive campus has only deepened and broadened. A deeper commitment, as Kristen mentioned, to sustainability is emerging as an organizing principle in the recent Task Force 21 discussions as we look to and plan for the future of MIT. And we recognize that not only are we positioned to lead and accelerate the science and development of climate mitigation strategies via research, as was discussed earlier in the previous panel and introduction, we must equally embrace our deep responsibility to understand how we at MIT are contributing to climate change and determine how to take responsibility for our own emissions and impacts locally to globally. Remember, to feed and fuel our 21st century lifestyles, we're currently overusing the Earth's biocapacity by at least 56%. It's so important for us. We are not apart from that, but rather an integral part of that and contributing to that. And this is a defining challenge for the world's citizens in the 21st century and for MIT. And at MIT, sustainability is framed by the need to promote health and well-being for a growing world population while reducing our global footprint to within Earth's capacity to sustain us. And as many of you know, this is so much easier said than done, and that's why we're here today. So in this brief presentation, I will share MIT's strategy as to how we are addressing sustainability and climate on campus. And hopefully by the end, many of you decide you want to join in and help us. And while the work of the Office of Sustainability at MIT is grounded in a campus-based approach, as you've heard, our collective opportunity is to address the complexity of sustainable development, justice, and the unprecedented climate challenge at the organizational and cityscape level in a manner that is informed by and maps to a global outlook. The actions we have taken and must continue to take range from the incremental to the transformational, and I'm willing to do both. We recognize that we cannot solve for sustainability within the walls of our campus alone, as we're completely integrated and reliant upon local, state, regional, and global systems. Keep in mind, at MIT, we have built a unique platform by which to address sustainability and the global climate challenge that spans, as illustrated here, across curriculum, research, teaching, strategic partnerships, and extracurricular student engagements, such as the renowned clubs and organizations. So my office is just one of many across this remarkable landscape. We set out a leadership pathway at MIT in which we set out to educate the next generation of students to confront and solve for complex global challenges, to engage our staff as lifelong learners who grapple with the complexity of sustainability in their daily work, to spawn new sustainability research among faculty, students, and researchers, and to transform our organization into an engine of sustainability practices, leveraging the campus as a test bed. And lastly, to act as a thoughtful partner in our communities. MIT's approach to solving for sustainability and climate is framed by a commitment that considers scales of impact in our understanding and analysis of solution development for and contribution to sustainability across the role of the individual, the campus, the city, and the globe alike. Underlying all of our work, as was referenced earlier, is a methodology of collaboration between research and operations, and a commitment to robust data collection and analysis in an iterative process. The Sustainability Data Pool is a first of its kind portal to campus sustainability data, which all of you who are with us today with an MIT Kerberos email can access. This is an expanding platform intended to streamline data access, track performance, inform decision makers, and catalyze research and teaching, and also enable, as was referenced earlier, a transparent approach to our challenges. And by centralizing campus sustainability information, the Sustainability Data Pool enables the MIT community to use the campus as a test bed to generate game-changing solutions to global challenges at the local level. In fact, today we have...
Were you planning to share that visually?
I won't get into it, but if we get into it in discussions, I can share that.
Okay, just wanted to make sure you were sharing screen if you planned. Thanks, go ahead.
This is an expanding platform intended to streamline data access across and track performance. And by centralizing this information, it enables the community to use the campus as a test bed. So as I started to mention, we have 3 active projects and a new course taking place in partnership with my office, enabled by our data collection process, a PPA supply chain and life cycle analysis, climate resiliency modeling, I'll share with you in a moment, scope 3 analysis of procured goods, air travel and commuting, and a course on exploring sustainability across scales. So for those of you who can see this, where it says Sustainability Data Pool, as Kristen suggested, you can log on separately. But today I'm just going to share the progress on just 4 of our priority areas that target our emissions portfolio, as well as how we are preparing for a changing climate. So I'm going to begin with climate mitigation, which you'll hear about in greater detail from Joe. We deliberately set our initial incremental greenhouse gas goal of 32% below 2014 levels by 2030, with our sights set on carbon neutrality, to enable us to understand the campus energy, building, and growth landscape. This provided the opportunity to build the foundation and understand the implications towards an accelerated path forward called for by science. We now understand the landscape, what it will take, and the challenge we face in reducing our emissions on campus. You'll receive an in-depth look at our path forward momentarily. In addition to mitigating our impacts, we also need to be prepared for the uncertainty of a changing climate. We're carefully analyzing the future implications of more frequent flooding, extreme precipitation, heat events, and rising sea levels. We're taking a long-term view in building, operating, and renewing our buildings and infrastructure to mitigate impacts from climate change. We are 4 years into a partnership with the MIT Joint Program on Science and Policy of Global Change, who are working hand in hand with my office, together with planning, utilities, insurance, emergency management, and others to analyze the impact of a changing climate on the MIT landscape. This work has informed the MIT flood vulnerability study that models campus flood exposure to small and large, chronic and episodic rain and storm surge events. So the findings will also be shared with the City of Cambridge and assist us in considering mitigation strategies at the site and systems level. And we are on the verge of launching this dashboard that reflects present 2030 and 2070 flood risk to align with that of the City of Cambridge. So stay tuned and keep coming back and looking for it. The third example I'd like to share is on mobility and sustainable transportation. So we recognize that how we move from place to place efficiently and responsibly is one of humankind's most enduring challenges. And to that end, we launched Access MIT in 2016 with an initial goal to reduce parking demand by 10% in true testbed form. The program incentivized a flexible commute choice for benefit eligible staff, faculty, and postdocs. And by providing free access to the MBTA, subways, buses to and from campus, the investment was combined with a shift to a daily parking rate rather than annual to disrupt the way the MIT community chooses to commute. Looking forward, we seek to expand the use of alternative fuels in MIT vehicles, optimize vehicle sizes, and improve transit routes and scheduling. We seek to advance an integrated transit system that optimizes the use of public transportation. I think something just changed. Oh, there you go. Ride sharing and non-motorized transport. I think something just changed here and it's not letting me, there we go. And we promote active modes of commuting such as walking and biking. And let's just note, since 2016, 350 fewer people were parking per day in gated lots, reducing demand by 14.9%, exceeding our initial goal. And over that same period, approximately 2,000 more people were using MBTA per day. Let's recognize that looking ahead, we will need to determine how to return to those trends and understand the intersection of new and emerging flexible work structures and mobility choices together with understanding public health implications in a post-COVID environment. New research partnerships have emerged to study these trends and inform our thinking as we navigate a new future. The final one is on materials management. We're nearing the end of a multi-year campus material flow analysis, measuring and analyzing the goods we bring into campus and our patterns of use and disposal. We are taking a systems approach to understanding our patterns of consumption and then working to design waste out of the campus system. COVID has brought new challenges upon us with respect to an increase in waste production, driven by the demand for PPE, single-use plastics, and other such materials used to keep us safe into the unforeseen future. And in an effort to understand the supply chain and disposal implications, we convened a team of researchers to study this phenomenon and inform a sustainable path forward that considers supply chain implications to end-of-life impacts. All right, somebody's gonna have to change that one for me. So in that end, MIT can and should be a global leader in addressing these unprecedented global challenges. We are now positioned to leverage our own researchers, faculty, and students to get ahead of the curve and not only prepare us for the future, but redefine the future as we strive to reduce our overall environmental and human health impacts. MIT's capabilities at the operational level with regard to design and construction, energy, transportation, food services, procurement, land management, and waste complement our academic and research endeavors, creating a mutual feedback loop to collectively inform and shape how we develop practices that enable us to stay within Earth's biocapacity. So in true MIT fashion, please join us to take on this 21st century challenge and figure out how to realign our collective impact with Earth's capacity to sustain us. And if you missed some of those slides, we can have them posted. All right, Joe, it's going to pass it on to you now.
So thank you, Julie. Thank you, Kristen. And Julie, thank you for your incredible team and all the work that they've done in the Office of Sustainability over the years. Truly, it's an amazing body of work and a huge credit there. So as Julie said earlier, I'm going to share some initiatives MIT is taking to reduce our carbon emissions, both on our campus and more globally outside of our campus. So many of you may recall that back in 2015, MIT set our carbon emissions goal at 32% and to get there by 2030. Our campus emissions today are at 24% below this baseline. And there are so many people on the call today who are instrumental in getting us this close to our goal. So thank you for all that you've done and for all that you're continuing to do to drive our emissions down on our campus. So the project teams who continue to incorporate emission reductions every day in our newest buildings, we're seeing significant decreases in those areas. There are teams working on MIT's next generation utility plant that'll be fully operational this spring, help us lower emissions and create a more flexible power system for future innovations. And we also continue to advance deep energy retrofits in our existing buildings and in our infrastructure. This is a core component of MIT's current and future energy reduction strategy. We also remain focused on renewables, both on our campus and off our campus, getting us closer to our goal. So in total, all the indicators are that we're on track, we're solid, we're moving forward to achieve our goal, hopefully before 2030. So what's next? Many of you have been asking us that in Julie's office and mine, and thinking beyond the 32% goal. Science is calling, we've heard, for an accelerated timeline, and we need to reduce carbon emissions faster. Over the past several months, we've been engaging many of you on this call today in a discovery process about what's possible, where can we go faster. This collaboration helps us better understand the landscape, the issues, the technologies available today, and what tomorrow's opportunities may be, near term and longer term. The collaboration over the last several months included, to name a few, the members of the Climate Action Advisory Committee, some of the leading experts in their field, the MIT Energy Initiative, and the Low Carbon Centers, the Energy Research, Education, and Outreach arm of MIT. We also spent a lot of time talking to our peer institutions, our industry partners, and our colleagues in the city of Cambridge. But especially we've taken time to talk to our students and our much broader community in a course that was developed by Professor Gutowski and Julie Newman called Solving for Carbon Neutrality at MIT, and put this tough problem in front of them year after year, and to see how they would solve it with given the facts of what we could do and what's possible. So I wanted to share with you a recent example of one such other collaboration. This happened at MIT's annual Energy Hackathon. This is sponsored by the MIT Energy Club every year. This is a very unique event that draws from participants all across our campus and disciplines, as well as all around the world. Over the course of 3 days, these teams, they split up and they develop innovative solutions to very specific energy problems that are posed to them. In 2018, the Office of Sustainability and the Department of Facilities submitted a very particular challenge for this hackathon. The question was, how can we use machine learning to reduce carbon emissions in MIT's buildings? Many of you might be familiar with the Nest thermostat. Thermostat that can predict what your space temperature set point should be against a myriad of variables of occupancy and weather patterns, usage patterns in the past, etc. So our question was, there is no equivalent for a Nest thermostat for large institutional buildings and large commercial buildings, which make up a very significant footprint, energy footprint across the globe. So we wondered what their vision would look like for the Nest, for these more complex buildings. And here is the hack that they shared with us. There were 3 specific teams that took on our challenge. They presented their machine learning architecture ideas and algorithms, and taking advantage of sensors and data networks from people in the buildings, real-time grid emissions factors, what class schedules were coming up across the institute. and what past and previous energy use would be, and then looking at weather patterns coming in. This enables MIT to use our buildings in a lot of cases like a battery. So we don't have to turn on the air conditioning if we know that it's going to get colder, hours, later. So there's the whole system is optimized to reduce carbon emissions. And there's actually a pilot in place today in one of our buildings on campus. So it's transitioned now to a collaboration between the MIT Quest for Intelligence, the Office of Sustainability and Facilities, and many others. So very soon, we hope to be seeing using this machine learning more broadly to reduce campus emissions, but perhaps this could be more broadly adopted globally. Another example I'd like to share with you is our ongoing efforts to convert our campus distribution system from steam to hot water. Most of the buildings on our campus today are dependent upon the original high pressure steam distribution system that was designed back in 1915. We've been taking steps over the last several years to evolve this infrastructure towards a more efficient, more reliable, safer, and resilient thermal hot water system. This is a very efficient design, widely adopted and used in Europe and other modern district energy campuses here in the US. We see this as one of the bridges to the next energy era. It's a multi-year implementation. It's going to take time. The first part includes a new hot water station that we're going to be constructing on top of Building 42, our existing utility plant on Vassar Street, you can see on the left. And we're also going to be adding new piping infrastructure to support some of our newest buildings. We will also continue to convert many of our older steam buildings over time to hot water buildings as renovations occur. So we also wanted to wrap up with a picture illustrating our most current thinking about a net positive posture for our campus. We are absolutely preoccupied with many ideas. You'll see a couple of them listed above here. And we're going to continue to reduce campus emissions where we can by leveraging these ideas. And there will be many others that we add over time. We anticipate there will be new future technology breakthroughs in this timeline and along the way, like we've learned from our experts here on the campus in battery storage, hydrogen, new nuclear, renewable fuels, fusion, and solar energy advances. We'll be ready to break when the breakthroughs happen. It's also important to say that we're considering all perspectives in our planning efforts, where MIT can have the most significant impact and to be nimble and flexible to whatever technology brings us in the coming years. So it's also to look at a companion picture to this, and that is off campus. Off campus, we're evaluating more opportunities to reduce emissions globally. Reducing emissions isn't just a Cambridge zip code problem, it's a global problem. And we're looking to build upon the efforts that we learned from our farm solar project and the teaming partnerships that we had with Boston Medical and the Friends of Post Office Square. MIT joined with these two local partners, which enabled the construction of a 60 megawatt solar plant in North Carolina just by virtue of balance sheet strength and no significant capital outlay from any of the organizations. Since Summit Farms, this aggregation model sparked many other fast following universities, state agencies, cities, and towns. A fast following with acceleration for larger and more renewable energy projects with the model that we put out there in the world. So now we're thinking about other new ways. What's possible to structure a portfolio approach for even larger carbon reduction type projects, not just solar and wind, but working at scale with so many more partners. These portfolios could be even more impactful and can be completed on very fast timelines, and that's what the science is telling us. So once again, this portfolio approach could be another new way yet of demonstrating a repeatable model for others to fast follow with a similar urgent timeline for action. So I want to conclude with a big thank you. A thank you to all the teams who are on the call with us today for all of your efforts in getting us to where we're at now in our carbon reductions on campus and rising to the challenges and all the hard work that's ahead of us. I'd like now to turn the symposium back to Kristen.
Thank you, Joe, and thanks, Julie, for your remarks. So we have many questions that have come in. I'm going to start asking ones most related to the campus and then moving out globally. So Julie, the first question is for you. You've really helped MIT focus on using the campus as a test bed and a living lab. But what are the biggest lessons that you think you've learned so far, you've helped the MIT community learn so far in the various projects that use the campus as a test bed? What are the biggest learnings? What is the biggest impact of that kind of effort?
Oh boy, that's a great question. Each project is so unique. I'll pick two examples. One I think is the climate resiliency modeling, which is an excellent example and demonstrates that these are such complex issues we're dealing with, and you can't take a single discipline approach to thinking about predicting the impact of climate change, for example, on the campus. So that's a great example in which I think we've got at least 12 different groups involved that include, climate scientists, engineers, insurance folks, our office, facilities, utilities, designers, architects, planners. It takes all of these disciplines to look at that single challenge to understand what the implications are at the community, infrastructure, campus, citywide level. So I think that's one of the lessons learned. And in terms of how to scale that up, I think therein lies some of the challenge that we want to continue to dig into. I think the other example is that we've now created this model that people have really responded to. And so, Kristen, when all of a sudden the challenge of COVID comes and we notice that PPEs are, we're going to have to start to grapple with the supply chain and use and disposal of PPEs. It didn't take but a couple of almost weeks to reach out and pull together a research team, an operations team, a finance team, and say, let's study this in MIT style. And we couldn't have done that a couple of years ago, but we actually now can quickly take these issues and really figure out how to get ahead of the curve, and we can do it. And it's taken us a couple of years to get that model in motion, and it's amazing what we can now do together.
Thanks, Julie. So it is helpful to point out that once you build that rhythm and that capability within MIT, a new challenge comes that you weren't prepared for, but you know how to pivot, such as how do you have sustainable PPE on campus during COVID times. Thanks for that. So if we step out a little bit beyond the campus, Joe, I'll take the next question to you. MIT is in the city of Cambridge. As I pointed out, we're in constant dialogue with the city. So the question was, how does MIT actually work with the city of Cambridge on adaptation and becoming resilient against climate change and mitigation measures?
Well, I'd say it's on multiple fronts. So the first one is on protecting ourselves from stormwater. Flood risk. So I know the climate model that Julie kind of shared with us, we've been actively engaged with the city in mapping all of our underground stormwater piping networks, feeding that into the city's underground network modeling. And we're now able to have some very reliable models that, we can simulate a different flood scenarios, flash floods, 12 inches of rain in 2 hours, and where the hot spots would be. And work very closely with the Department of Public Works within the city. So planning a lot of the infrastructure improvements. Just this past year, we completed a project for a major storm pipe outfall for Cambridgeport, which really relieved a lot of significant issues that they had there. And that came right through our campus. It was a very difficult problem for all of us to solve, but it's something that we are in constant contact with the city folks, whether it's on a planning, infrastructure planning front, or even on the energy planning front as well. So thinking about new building construction, renovations, a net zero building ordinances, so we provide a lot of information and guidance and science, and so that we can come up with a complementary strategy that works for both the city and for MIT and other stakeholders in the city as well.
Thanks, Joe. So, Julie, I know that you work closely with others, including Mike Owu, thinking about MIT's parking and transportation system on the campus. And MIT's made great strides in terms of enabling public transportation measures to reduce driving to campus. But the question goes beyond the campus, and it's really about how have we measured the carbon that relates to the travel that MIT engages in, including MIT work travel. And while that's obviously not an issue right now, it is a question that we've talked about and thought about. So can you respond to that? Have we measured carbon from all of MIT travel? What do we think about that at this time as part of our climate contributions and adaptations?
Oh, that's such a great and thoughtful question, and one that's been on our mind since the emergence of the first plan for climate action. Um, so of course, yes, this is something that we've been looking into from the get-go. And we've been so deliberate in how we've started to set ourselves up for responding to climate change or setting ourselves up for climate mitigation at the campus level by starting with our scope 1 and 2, basically energy, the energy needed for the campus to run. And while that was getting up, churned and getting up and running, and the data was available and available to not only collect but to replicate in a rigorous way at on the annual basis and now a quarterly basis. At the same time, we've been working to understand what are our scope 3 emissions. So I'm sure the person asking the question is thinking about what about everything else. So that's been on our mind all along. So we have been working for a number of years. We have a research fellow in our office, Jeremy Gregory, who's been working hand in hand with us for about 3 years, trying to collect the data on looking at scope 3 with respect to, emissions with respect to procured goods, air travel, commuting travel, embodied carbon, so that we can get that portfolio up and running. We've been reaching out to our other peers as well to see what their methodology is and what the appropriate boundaries are for an institute. So stay tuned on that. And I think it should absolutely be a part of our discussion moving forward. But please know it's not coming from a reactionary place. It's coming from how do we collect really good, rigorous data to understand that. I think that's really, really important. So I'll only add one more piece is that our good colleagues in the School of Architecture and Planning have gotten ahead of the curve on that and worked closely with us this summer to start to get their portfolio of air travel in place. And it's an excellent testbed model at the college level, departmental level, to understand and start to grapple with what is the air travel, what are the implications of air travel, and how do we ensure we can still get our work done and it's still mapping to the scholarship and partnerships needed. Anyway, what are those appropriate ways of quantifying that information? And then what kind of steps can be taken to mitigate that? So we look forward to working closely with the School of Architecture and Planning leadership on that.
Thank you, Julie. So all of this, what happens on the campus, what happens in the city, what happens as we all start to travel again as part of our work and living and learning, this is very much on the minds of Julie, of Joe, of the rest of us. So I'll share in the thanks for all of the effort you put in, all of the leadership you put in for helping to make this easier. And also just emphasize that a reasonable question to ask is, what are the obstacles to making MIT net zero? And Joe shared graphically that those obstacles include technology, but they're not only technology. There are choices, and then they're the technology that we need to develop and choose to implement together and to work broadly in the country and around the world to make that more possible. So thank you both.